In the current section, I will try to introduce you on the applied research of photosynthesis as well as its industrial application. At the end of this section, you will have been familiarized with the terms of secondary metabolite and its industrial production. Then you will have been introduced on the variety of different reactors and their positive and negative aspects. Lastly, I hope that you will think the importance for applied research in general. So let's start with a common sense question about what would be the use of the wheel if that would not have been transformed into a vehicle. What would be the use of a gear if that would not have contributed in the construction of a more complicated machine? And at last, how limited would be the significance of research if that would stay only in research documents, articles and conferences? So the question arises, and we will try to address that question in the following slides. So a small compound but with high importance is produced in plant cells, and it is studied in the field of natural product. This is metabolite, a small molecule that comes as a result of metabolism. A metabolite can be either primary or secondary. In order to introduce the term of metabolite, it would be useful to define the differences of primary and secondary metabolites. Firstly, the phase of the microorganism is characteristic for the production. While primary metabolites are produced on growth phase, the secondary are expressed on the stationary or late exponential one. Primary metabolites are expressed in higher quantities, and thus their extraction and isolation is easier. On the other hand, the secondary, which are expressed limitedly, and thus their extraction faces difficulties. Primary metabolites also have a significant role for the viability of the cell, while the secondary does not. Vitamins and alcohol are some examples of primary metabolites, while antibiotics, essential oils and toxins are from secondary. In the following graph, we can understand better the phase where each metabolite is expressed. And as we mentioned before, the metabolites could have several applications on people's lives in different aspects, from vitamins to antibiotics. And on the same way that from a pot we cannot produce enough fruit to adverse in a small community, we cannot produce enough quantity of metabolite from a flask culture. So while a flask culture could provide sufficient amount for an experiment in a lab, which structure would produce the relevant quantity for industry? That question was replied on late 50s when the first photobioreactors were developed in USA, Germany and Japan. On the following decades, the size of these reactors grew for cultivation of chlorella and spirulina. Through the time, that production continued to grow more and more and resulted in an extended production in late 80s in Asia and more specific in the region of India. So the reactors could be split into categories, the open and the closed systems. Let's start with the open reactors. The open reactors have some advantages, as they can be built easily, and it's easy also to operate. At the same time, have low cost. However, the danger of contamination is always present, and we cannot regulate easily the external parameters like temperature due to the water evaporation. The following are some typical examples of open reactors, like the raceway pond, circular pond and unstirred pond. Now regarding the closed systems, in contrast with the open reactors, we can have the advantage that we can control easily the external parameter like light intensity, pH and temperature, while on the same time we can minimize the danger of contamination. As we can easily understand, they occupy much less space. However, on the same time, they have a higher cost of building and maintenance, mostly because of the energy consumption due to external lighting systems. The following, like stirred tank, bubble column, horizontal tubular and flat panel photobioreactor, are some typical examples of closed reactors. To recapitulate, the importance mostly of secondary metabolites leads to the increasing need for higher industrial production. And in that field, from open to closed photobioreactors and reactors, there is a continuous development on new systems with the tools that the research on photosynthesis provides. However, I think that from the current presentation we can assume a wider idea than just the use of photobioreactors and even that of photosynthesis. Let's talk about art. If we think about it, in order to be successful, the art should be addressed to the people and not in some special audience. In the same way, when research, not specific about photosynthesis, when the research is applied and it doesn't stay only to scientific circles, congresses, documents, then it always has a greater impact.